So first definition, trig functions of theta. So this would be a more general definition for sine, cosine, tangent, etc. It'll be because the other ones have been for a unit circle. So r was always assumed to be 1. So here we're going to assume r is anything greater than 0. So let theta be any angle in standard form. Actually, standard position, sorry. And let AB denote the coordinates of any point except the origin.
And the origin is 0, 0, right?
Yeah, 0, 0. On the terminal side of theta. If r is equal to the square root of a squared plus b squared, sure. So I'm sorry, let me phrase that better. So everything what I wrote is fine. So if r denotes the distance from 0, 0 to AB, so r is defined as this, and it denotes the distance from 0, 0 to AB, then the 6 trig functions of theta are defined as ratios. All right. So all that stuff just to say this, and sine theta is equal to b over r. Cosine theta is equal to a over r. Tangent theta is equal to b over a. Cosecant theta is equal to r over b. Secant theta is equal to r over a. Cotangent theta is equal to a over b. So let me give you a brief picture as to what that paragraph was saying. One second, I'll let you catch up. No rush here.
So does R stand for the radians?
It's going to be the radius. So this is what R is, right? So we have some angle. We'll call theta, going all the way this way.
Could you bring your paper down a little bit?
Oh, yeah, sorry. So over here, we have some point AB. That's what these A's and B's are referring to, okay? And how far I went out, how big is the circle, is R. Okay, but, and I don't want you to feel concerned or confused, but this is all the same stuff we've already been doing. The only difference now is that, you know how before, let me show you a picture on the unit circle. Before we had sine equal to just the y part, right? Sine theta. Where is my circle? Here it is. Okay. All right, so so you see how sine of 30 would be 1/2, right? We're more comfortable with this now. So now it's no longer just 1/2. It's going to be this value, whatever it is, divided by r. That's the difference. So all of this is a circle of radius 1, so it goes out 1 unit. But now these questions could be a circle that's bigger, like radius 2 or 4, whatever. So it'll be very similar to what we've already done. It's just that we have this extra r part. So it doesn't come up too often, but it will in this section. All right, but we'll do those examples in a minute. Now let's write down some more definitions. So this section will talk about this homework, coterminal. Coterminal angles. Two angles in standard position are said to be coterminal if they have the same terminal side. So basically, you know how we can go around a circle over and over again and land in the same place. So that's what we mean by same terminal side, okay? So like, let's draw some circles here. So this is the 45-degree angle. And this guy is going to be the same angle, but I went all the way around and then landed here. See what I mean? So this theta is 405 degrees. Let me write that better. Does that make sense? You see how it's the same thing? Let me show you a better actual visual, because
would negative 315 be the same, also coterminal?
I can't hear you very well. You're far away.
Would negative 315 also be coterminal?
Will negative 3 something.
315? One sec.
Yeah, yeah.
Can you hear me better?
Yeah, yeah, it sounds great now.
Okay. Yeah, I guess my headset was plugged in. Would negative 315 be coterminal, or is that something else?
Well, let's look
Does
at
it
it,
have to-
right? So 45 is right here, right? But if I were to go all the way around and land on it again, that's going to be 405, right? Because it's 360 plus 45 gets me here. So those two angles would be coterminal for sure. 315 is down here. So there are other angles that are coterminal to that angle. I don't know if it would say that these are coterminal to 315.
Oh, I meant negative 315, like go in the opposite direction.
Oh, negative.
I don't-
I got you.
I don't know why it felt like when I was doing the homework, that was like the type of examples they were giving.
Mhm.
Maybe I was looking at the wrong thing.
Oh, did they accept the negative angles and stuff for coterminal?
Yeah, it looked like they were going like clockwise on one of them and then counterclockwise on the other, but
Yeah,
Could
I
have been
think
looking at-
as long as you land on the same place, it should be fine.
Okay.
According to the definition, it says two angles in standard position as long as they have the same terminal side. Yeah. So, give me 1 second. Let me double check one thing that's bugging me. I want to say yes, but before I say absolutes, I need to back it up. 1 second. Where is this formula at?
But it's because they land in the same quadrant, right? That's what you mean by same place?
The exact same spot in that quadrant.
I don't see the same spot.
So
I see two different spots.
yeah, so that's why I pulled up that picture because my drawing's crappy. Here, 1 second. Where is Zoom at? So this is what I'm trying to draw. So the first picture on the left, the first circle here, or whatever, is at 45, right? And that's what I drew. Now, if you go all the way around and land on there again, that's 405 degrees. So I have to land right on there. If that happens, then those two angles, the 45 and the 405, are considered to be coterminal. You see what I'm saying? Let's see here.
Yeah, that makes sense. So then they have to
Oh.
go the same direction then clockwise.
Yeah.
Because it
So
would be on the opposite side the other way, right?
mhm.
So they're landed on the same spot as on the arrow, I guess is
this
what you
guy
mean?
right here, this angle. Yeah.
The
So
line,
right. So the arrow will say right here. So I went from this is 0, right, and this is 45 right here, 45 angle. Let me go back to the paper. Yeah, the arrow picture it pointing right here, and then if I go all the way around and land on there again, that's 405 degrees. Right? It's 405. My crappy writing on this. So going straight there from here to here is 45, and then going all the way around and landing there again is coterminal. Does that help?
okay. Okay, I see it.
Okay. Okay, now let me look up a definition really quick. Yeah, so go negative, positive, or whatever, as long as they land in the same place, coterminal. Okay, let's keep going here. You guys have any other questions on coterminal? Okay. So these two. Okay. So it's talking about reference angles. This is a little weird, but it's not too hard. So let theta denote an angle that lies in a quadrant. The acute angle formed by the terminal angle or terminal side of theta, terminal side of theta and the x-axis and the terminal side of theta and the axis is called the reference angle. Okay. Okay, so let me draw the pictures because I know the definitions sometimes are hard to read and understand. But once you see it, I think it'll be okay. Let me get, well, let's see if I have another color. Okay. All I have is dark black and, dark blue and black. Oh well. Gotta pick up pens. Okay. All right, so let's say this is your angle, right? You go from here, the 0 point, all the way to some theta, right? So you start here, and you sweep across all the way to that angle, right? The reference angle is going to be, I'm going to try to see if you can distinguish the colors, but this is the black right here. So that angle here is called the reference angle, that distance. Okay, so if they ask you for a reference, that's what they're talking about. how far am I from the the x-axis, right? That's what the definition said. Excuse me. All right. I'll give you a couple examples because there's different scenarios. So let's say your angle goes all the way down here. What is the distance? I'm going to write it in black. From the x-axis from that angle. So we'll call that, so this guy right here, draw my little arrow, is the reference. It's a crappy arrow. Okay. Does that make sense, what I'm saying? So if I show you the unit circle, this is what I'm talking about. Okay. So here is the angle 150, right? So let's say I'm at 0 and I go all the way to 150 and I draw my arrow here, or whatever. You don't have to draw an arrow, just put a line from here to here. So the distance from here to the x-axis, which is of course the horizontal line, is how much? What would you say that is? Or how far is it from here to here?
30 degrees.
Yeah, so the reference angle for 150 degrees is 30 degrees. That's what that definition is saying that we wrote down right here. Okay, and that's what I'm trying to visualize for you. So does it make sense?
Yes.
Okay.
Is
All right.
that kind of the same, like how you had the 45 and the 405? Like, would you just like subtract what was like the 405 from the 45? Would that be the reference angle? Or am I totally like thinking about this the wrong way?
I don't think that I don't think it would work, but I don't want to say
No?
no.
Okay.
But well, we'll try a couple of examples in a second. We'll see what's the easiest way
Okay.
to find them. But let me give you a couple more pictures and then we'll start. Okay. So we'll go all the way over here to this angle. Reference would be here. From here to here, the distance. Oops, somebody's trying to enter the classroom. Okay. I'm trying to find a cool visual for you. Oh, this will work. Nice. I like this. Let's ignore the ads, okay? All right, so here's your angle, the blue one. I'm sorry, the black one is the actual angle. So right here at 0, starting position. If I sweep to 45 or whatever, the reference angle is equal, right? Because it's the same distance from the x-axis. But if I get over here, it starts to be different. So now I'm at 125, the reference is 55. That's the distance to the x-axis. Now earlier we mentioned 150, right? Distance was 30. Now if we're down here, I am at 220. Reference would be 40. And over here, same deal. The distance to the x-axis. If I'm at 315 degrees, the reference angle would be 45. Does it make more sense? Now, if I have a negative angle, does that change my reference angle? Still the same idea, right? You're still trying to figure out how far am I from the x-axis? How far am I from the x? That's what the blue is telling you. Okay? All right, let's see here.
Reference angles are far you are from the x-axis.
Yeah, so you have your standard angle, that your usual stuff, right? And then you check the reference, which if they ask for it, right? Reference just means how far are you from the x-axis. That's it. And then coterminal is just an angle that is equal to the one that you're talking about by going around again or going negative or whatever. Okay. Okay, let's see. All right, so let's start some examples. Okay. Where was I? Yeah, example 1. So use a coterminal angle to find the exact value. All right. So let's say you're given sine of 1,110 degrees. And you're like, you know what? That's not on the circle. That's too big. But that means it went around the circle a bunch of times, right? So we do know that one circle is 360 degrees, right? Going around all the way around, correct? So 0 is starting here. If I go around one time, that's 360, right? If I go around the circle again, that is 720. If I go around again, what would it be?
900. Or no, 1080, 1080.
1080, right? Thanks. So how much is left after I go 1080? Because that's supposed to go to 1110, right?
30.
30 degrees. So the actual angle would be right here. So this nonsense that I drew is 1110 degrees, but the coterminal angle is 30. So really all you have to look at is this guy, right? So 360 over and over again. Eventually you end up at 30 degrees. So the coterminal angle is 30, so we'll just use this one. Sine of 30 would be equal to this question. Which would be 1/2, right? And if you're wondering, like, well, how the heck do I do that? What you could do, instead of drawing this stupid picture, right? You could just look at the 1110 and subtract 360 over and over again until you run out of, until it's too big to subtract. Does that make sense? That's
Mhm.
basically what we did here visually, right? So 1110 minus 360 is what?
Mm,
We can no, you can pull a calculator if you want. So don't feel bad.
750.
750. Okay. So then we do 750 and subtract another 360. What's that going to be?
330. I mean 390.
390. And
Yeah.
then 390 one more time because it's still bigger than 360. Subtract another 360 and I'm left with 30, right? Do you agree with that?
I agree. Where did the half come from though? I think I missed that step.
Oh,
for
the
me.
half. So once you get to 30, you just look up what is sine of 30 on your circle.
Oh, okay. Okay.
And that's the y value, 1/2.
Okay.
So that's why coterminal is helpful, because this giant angle is really the same as 30 degrees. It's just that I went around and around for whatever reason. Is there any questions on number 1?
This is calculus, right?
This is trigonometry, technically. We are in pre-calculus stuff.
Or pre-cal, I meant.
Yeah. So pre-cal, I think usually we use that term to refer to the trigonometry. But yeah, I think you're right.
Okay.
That first thing we did in chapter 12 with the partial fractions, that was just an algebra topic.
Right, yeah.
Okay. You guys cool on number 1? I'm going to do a different one.
I think so.
Okay, so there's not always going to be degrees, so they'll try to trip you up on the homework by giving you an angle that is in radians, and those are harder to subtract because they're fractions, right? Use a coterminal angle. It's still the same question. Use a coterminal angle to find the exact value for this guy. Sine of 9 pi over 2. So same idea, it's just not degrees. So it's the exact same thing. So what I'm going to have you do, well, first of all, 360 is equivalent to what in radians?
Pi over 2.
It's close.
2 pi.
2 pi.
2 pi, right? So what we can do is take this fraction and just subtract 2 pi over and over again until we end up with something that is less than 2 pi. You could also change the degrees and just subtract degrees if you don't want to deal with it.
Is
Technically,
that a pi or
it's a 9, so a really bad 9.
Okay.
So if just for the practice, I'm gonna leave it in radians. So what you would do, 9 pi over 2 subtract 360, right? In other words, 2 pi. How do you subtract these fractions? Well, common denominator is required. So this is technically over 1. So you would multiply the top and bottom by 2, right? That would give you 4 pi over 2. So I skipped a step here. Do you see where this came from? The 4 pi over 2.
So 4 pi over 2 is the same as 2 pi.
Right. So the step that you would do is multiply top and bottom by 2. That way they're the same. And now you can subtract. So 9 pi over 2 subtracted by 4 pi over 2 is a 5 pi over 2, right? So now we have 5 pi over 2. Still bigger than 2 pi, so subtract another 2 pi, which requires another 2 over 2. So 5 pi over 2 minus 4 pi over 2, giving us a pi over 2. So now now we have something less than 2 pi. So we removed enough circles, enough 360s, right? If we were to do it in degrees, I'm going to do the scratch work up here. If you were to convert it, right, 9 pi over 2 times, the conversion factor would be 180 degrees over pi, right? Remember we did this in homework 1, homework 2, I think it was. That would give us 9 times 180 over 2, which would be what? What is that?
That's 360 times. That's 360 times 4, right?
810.
Yeah. 810. So what you could do is take the 810. So this is the same, right? And subtract 360 if you don't want to deal with the fractions, which would give us what? Excuse me.
450.
450. Thanks. So then do it again. Still bigger than 360, right? What would that be?
It will give you 90.
90. So these two are the same deal. Okay. And this is all the same concept. It's just that one has fractions and one doesn't. So once you change it, just find what is sine of pi over 2, or if you prefer, sine of 90. That would give you 1. So how many times did we go around the circle?
You're talking about
On this 9 pi over 2.
4
Nice.
times? Oh, no. Okay.
2 times around plus 90.
Yeah, so it'd be 1, 2, and then 90 up here. So pi over 2 is right there. So 1, 2, 90.
Oh, okay. Yeah.
Or radians, whatever. It's up to you. So I don't mind if you convert it. If you just don't like the radians, you can. But at some point, you should get comfortable with radians. All right. So now let's move on to reference. Do you guys have any questions about coterminal angles?
So the answer, to find the exact value, it's just 1?
Yeah, that's given by the circle right here. So the y value here is 1. Right?
Uh-huh.
So that's it. That's what they're asking. So they're asking what is the value on the circle for sine of 9 pi over 2. But it's not on there because they went around too many times. So you find a coterminal instead. That's the whole idea. The big
Okay.
picture, I guess. Any other questions on coterminal?
And sine is always the r or the y value, correct?
Yes. All right. Let me take let's take a short break here. 6:55. Come back at 7:05. And we'll start reference angles. I'll send you a. Oh, actually, we'll wait on that. Okay, so here's our example 3. given an angle of 125, what is the reference? How far is it to the x-axis? So if it's not on the circle, you can just basically subtract from 180, right? I think that one might be. Let me see.
I think it's 55 degrees.
Yeah, it looks like it. Because we know going all the way around, all the way to this line here, right, is 180. So how much further do I need to go? Well, you would subtract. So the reference angle for that quadrant would be just simply 180 minus 125, which is 155. Does that make sense? Okay. Okay. So let me give you some theorems and we'll move on from this. The theorem for reference angles. Theorem for reference angles. So if theta is an angle that lies in a quadrant and if alpha is its reference angle, then the following is true. Sine theta is equal to plus or minus sine alpha. My alphas look like Jesus fishes, but it's whatever. Cosine theta is equal to plus or minus cosine alpha. Tangent theta is equal to plus or minus tangent alpha. Now I'll tell you how to determine the plus or minuses. That will be determined by the quadrant. And I'll give you a little chart in a second. Cosecant theta is equal to plus or minus cosecant alpha. Secant theta is equal to plus or minus secant alpha. Cotangent theta is equal to plus or minus cotangent alpha. All right. So where how should I phrase that? Yeah, I'll fix this. Plus or minus is decided by which quadrant theta lies in. So if it is in quadrant 1, the plus or minus, they'll both be plus here. Here it'd be minus plus, minus minus, plus minus. Okay. All right. Do one more example and move on to 7 to 5. 7 to 5, there's not much to do. It's just really a ton of definitions or properties. And understanding the domain and range for the trig functions. Either get that down or at least put it on a formula sheet and you should be fine. Because I'm not going to make you graph it by hand, which, you know, we used to do. Since we have graphing calculators, I'll try to go easy on you. Or if you use the graphing website. All right. That's cool if I turn the page or not yet.
So what does plus plus mean? Like, what does plus minus mean? What does that mean as far as how it's going to be sine?
So if it's sine, you would look at the y value, right? So let's put a comma in there, make it more clear. Consider this x and y coordinates. So sine would be negative, or would be negative in quadrant 2. I'm sorry, quadrant 3 and 4. Cosine would be negative in quadrant 2 and 3. So if you were to convert some angle theta to alpha, you would have to pick plus or minus. So the plus or minus would be determined by the location of theta. So if theta is in quadrant 2, then you would put a minus on this guy.
And would we just convert like tangent or cotangent to sine or cosine in order to figure that out?
No, tangent would be the same. It'll have it's the same deal. So if it was tangent, oh, you're asking like how would you find the values, or what do you mean?
I guess like how would you, like let's say it's secant, like, well I guess I guess tangent. Sorry. So yes, would it be plus or minus? Like how would we determine that?
Tangent would be, let's see here. That's a good question. Now I think about it. Because it is a quotient of sine and cosine, right? So tangent would be positive here and there and negative elsewhere. So similar to how you found tangent on the unit circle before. So let's say we had tangent over here, right? That value is going to be negative. So if you were to use the reference angle, which would bring you to the quadrant 1, you would have to tack on the minus because tangent is negative here. If your tangent was here, though, it would stay positive, so you wouldn't have to. So just remember what is tangent, right? What are the angles? Because we can't be talking about reference stuff if you're not using the basic thetas, right? The unit circle stuff. So real quick. Right, so tangent would be positive here because it's a quotient of y over the x value, right? So over here, tangents would be negative because one of them is negative. And we know dividing by a positive by negative is negative. So anything in here for tangent is negative. So if you use a reference angle, let's say tangent of 150, right? The reference is 30, so you can convert it to tangent 30, but you would have to put a minus in front.
Okay, I got you. I must have missed somewhere that tangent was y over x. I must have missed that somewhere. Thanks.
Yeah, well, yeah, I guess I didn't outright say it, but it's implied because of the sine over cosine is equal to tangent, and sine and cosine are, right, y over x.
Yeah, okay. Yeah, that part. That's the part that I must have missed on. Thank you.
Yeah, no worries. Glad you asked. use reference angles, or use the reference angle. To find the exact value of a trig function. Let's do part A. So sine of 135 is equal to sine of its reference angle. So what is a reference angle of 135? Degrees.
45.
45, right? So you can change it to 45. That's what the theorem is telling you. You just need to choose if it's plus or minus. Well, is sine positive at 135?
Yes.
Yes, right? So we go to 135 and look at it. The y value is positive, so therefore I leave it. I mean, you don't have to write a plus, so you just leave it positive, right? If it was, let's say, cosine of 135, that would be equal to cosine of 45. But since cosine is negative, right, on the quadrant 2, you would have to put a minus. That's what that picture was saying, because of the x value. Does that make sense?
Could you show the picture one more time for the cosine?
Sure. Where is it? There it is. So cosine, you see how all the x values are negative, right? So since I'm doing cosine of 135, the reference is 45, so I can change it to cosine 45, but I need to make sure that I put a minus in front because of this. Because if I don't, it would be wrong, because cosine of 45 is positive, right? Does that make sense?
And how is that different from the sine?
Sine is positive, so you don't have to put a negative on it. See how their sine is positive here and sine is positive there?
So because of them being on the X or the Y.
Yeah, so it depends. So the first thing you look at is where is theta, right? So 135. And then, so we go to 135 and they say, okay, they're talking about sine. So I look at the y value. Since it's positive, I don't have to worry about putting a minus on it. So I can change it to sine 45. And you see how this answer is the same as this answer, right?
Mhm.
So that's why they're equal here.
But how do you know that how do you know that sine is on Y?
Sine is always the y value on your unit circle.
And then cosine is X?
Yes.
But how do I know that?
What do you mean? That's just
Like
that's how it's defined. It's just,
Oh, it's defined that way.
yeah, it's a definition. Cosine will always be the x value here. So at the very beginning, let me show you. Right here, right? We said that cosine is defined to be a over r. So a is the x value, right? So since r is
We
1,
can't see the paper.
oh yeah, that's right. My bad. Sorry. All right. So since a is the x value, right? Cosine is defined to be a over r. Then cosine would simply be a. But since r is 1, we don't have to worry about it. So this is a more general definition. But at the very beginning of chapter 7, we said that cosine is equal to this x value. Excuse me.
Now
So,
it makes sense. Thank you.
yeah. So if you were to do tangent, right, you would divide these two, because tangent is sine over cosine. So you would divide 1/2 by this, square root 3 over 2. Okay, let's do one more and we'll move on to, yeah, we'll move on to 7.5. Sorry, I got distracted. Cosine of 600 equals cosine of 240. I skipped a step here, but let's go through it. So 600 is more than 360, right? So subtract 360, who gets us to 240. So this is the coterminal angle here. So now use your reference angle. What is the reference angle of 240? So let's look at the circle. If you, I don't expect you to do it in your head. So 240 is right here.
60, right?
Yeah, it looks like you're 60 degrees away from the x, right? So we can change this into, instead of cosine 240, you can change it to cosine of 60. Do I put a minus in front, or do I leave it as a positive?
Be a negative.
Yeah, we put a minus because cosine is negative in the third quadrant here. All the x's. Actually, everything is negative here, so to put minus. So then cosine 60 we know is just a 1/2, right? And then the minus is there waiting for you. And that's it. And this guy would be, I forgot to write the answers, but I'm sure you knew them already. Any questions on coterminal angles or reference angles?
This might seem like a silly question, but when we're looking at saying like 15 is the reference angle, like 15 degrees is the reference angle, and we would mark it as negative in order to show that it was on the second quadrant. Would we know just by looking at that it was the second quadrant, or since there's like two different ways, we wouldn't really know of determining, like there wouldn't be a way to determine which is which? Does that make sense? I know that's a lot of.
You're talking about like, well, it all depends on the original angle. So you have to first say, what is theta, right? So like, is it 240 or where's theta at?
Sure, what I guess what I'm saying is like, if we have negative square root of 2 over 2, would we know like where that was? Never mind. I'll ask you later if it makes sense to me later.
I think I might hear what you're saying. You're wondering if you know the value, can you kind of figure out which angle it is?
Yes.
You can narrow it down
between the two, right?
Because there's going to be two spots, right? Like for example, square root 2 over 2 happens at 45, but also at 315, right? So it could be one of these. It depends. So depending on the question, you could be able to narrow it down, but without any other information, you can only say 45 or this guy. That's about it.
Okay, but they'll be 90 degrees apart, right? Like that's kind of what I'm seeing on all of those.
Yeah.
Cool. All right, cool. Thanks.
Trying to find if there's a case where that's not true, but I'm pretty sure you're right.
For the one that we just did, the 240, the COSI 240, and we got 60. I think I get it. It's the 240 minus the 180, so we get the 60. The only thing I'm not getting is where we got the negative 1/2 on. Are we looking
Oh,
at the
okay.
60 on the right side, or?
Yeah, so once you get to cosine 60 or negative cosine 60, the
Okay,
answer is 1/2,
So
right?
we do go back again to the, okay, I got confused because it's, okay, why is it negative? That's what's confusing me.
So the negative was determined by the theorem over here. Remember we said if you're going to convert it into a reference angle, let me switch back. We have to put on a minus, plus or minus sign, right?
Oh,
And that is determined by where the theta is at. So we have to choose plus or minus. And we determine that here. So let's just go over B one more time. So B is cosine 135, right? That's quadrant 2 where cosine is negative, the x values, right? So because of that, I can convert it to cosine 45, but I have to put a minus to make up for this. Because if I don't, it would be positive, right? And it's not supposed to be.
Oh, okay, so no matter what, if you're using the degrees on the right side, if it's, because it's a negative, you just add a negative.
Right. So if it's supposed to be negative over here, then you convert it to something that's not negative, you put the negative.
Okay, I think I get it. Okay.
So yeah, you just look at where is theta, and that will determine if you put a plus or minus.
Okay. Thank
So I
you.
drew that little circle down here.
Did you do one of the problems with the tangent, like problem D? The cosine of sine makes sense to me. The tangent is a little more difficult. I just would like to
Okay.
follow along
Let's
with
do
like the pi,
tangent.
negative pi over 3.
You want to do a negative angle?
Well, it's got the problem D is the tangent and then parentheses negative pi over 3. I just like to understand.
Okay. Well, negative pi over 3, that's going to be down here, right? Because it's the same as 60, so negative 60 would be here, correct? So the coterminal, so let me make some space here. First, you change it to coterminal, and then change it to reference. Let me write it again. So tangent of pi over 3, negative. That's the same as tangent. I'm going to change it to degrees just so it's more obvious for this question. All right. So we have tangent of negative 60. So the coterminal would be tangent of 300. Right? Because if I add 360, I'd go all the way around and be at the positive side. So instead of going backwards, I can go all the way around to get to the positive angle. So I can go this way, negative 60, or go all the way around to 300. Does that make sense? The first step.
Yeah, that makes sense.
Okay, so once we have it, what is the reference? So if I'm right here, how far away is the x-axis?
60.
Yeah, so this is going to be equivalent to or equal to tangent of 60, but now we got to decide, is it plus or minus? So we look at where theta is, we're in here, and 1 is negative. So that means if I divide them, the tangent will be negative. So you would choose to put a minus in front of tangent. Because the only way tangent is positive is if they're both positive or both negative. So that tangent is only positive in quadrant 1 and 3. So if I'm anywhere else, tangent will be negative. Do you see why?
Yes.
Okay, so then show a little extra work just for fun here. Switch back. So
You
tangent,
said tangent is only positive in quadrants 1 or 3, right?
right.
Okay.
All right, so tangent, negative tangent 60 is going to be, so here's 60. So divide these guys. But the minus will be out in front. So minus is right here. Divide the y, square root 3 over 2, divided by the x. When you divide these, you divide fractions by multiplying by the reciprocal, right? So the answer would be negative root 3 for tangent. Is there any questions about D?
So what was the bottom part that you just did?
Well, I did an extra step because tangent 60 means you have to get the y and the x, because this is sine over cosine, right? So tangent is. So you'd have to go to the unit circle and divide this value, the sine over cosine. So whenever you have a tangent, there's a little bit more work. So then that's what I did here. And that minus is from the formula, right? The theorem. So I do my math here, fraction stuff. Once I'm done, minus stays.
Okay. So that's literally the end of that problem, just because it's a tangent.
Yeah, it's the same as ABC. It's just that tangent makes you do a little extra work. Unless you were to write down every single tangent value, but that'd be silly. Okay. Any questions on 7.4? All right. Let me give you okay. So the next one is just a lot of definitions and properties. Not many examples really, but we'll do some. Hopefully. 7.5, unit circle approach. Properties of the trig functions. Periodic properties. So basically this, I'll show you graphically in a moment, but here's the actual property. So if you're giving a sine and you have some random theta and you add 2 pi, that will be the same as just doing sine of theta, right? Because that kind of is an extension of the, what's it called? Coterminal ideas, right? We've known that if we keep adding circles, it's the same thing as the original angle, right? Like 30 plus 360, I'm still going to land on 30. So cosine, same property. So if I add 2 pi, that's the same as if I didn't do anything and I just had theta. Okay. Cosecant, same deal because it's a reciprocal of sine. So it's just cosecant theta. Secant, same thing, is equal to secant. Now tangent and cotangent are a little bit different. This one will, if you add pi, it will be the same as a 1 period, 1 circle. Cotangent theta plus pi equals cotangent. All right. So that's the first one, first set of properties. Next one, even and odd properties. Do you guys remember what even and odd functions? College algebra.
Yes.
All right. So a function, well, I'm going to define it one more time just in case you forgot. A function is even if this happens. If f of negative x is equal to f of x, meaning that if I plug in a negative value, it'll absorb the negative, and it behaves as if I were to have plugged in the positive x. Makes no difference. So like if I plug in 2 or negative 2, I get the same output. Doesn't change. That's the definition of even. A function is odd if f of negative x is equal to negative f of x. So an odd function is odd if you plug in a negative, that's as if you plug in a positive but made the entire function negative. And I'll show you some examples in a second. Because odd is a little harder to picture, but once you see it, it's not a big deal. So this guy right here is even. That's a parabola, right? It passes the definition because if I were to plug in a negative 2, I get a 4, right? Because that would be the short word. That would be negative 2 squared equal to 4. Right? Do you agree?
Yep.
And if you plug in a positive, you see how that's the same deal, right? There is no difference, negative x or positive x, 2 or negative 2. So that's going to be, make a note here. It's even because of that definition. Now let's say you have a g of x equal to x cubed plus x. If I were to plug in 1, that would give me 1 cubed plus 1, right? Do you agree? So that would be 2. Now, if I plug in a -1, that would be -1 cubed plus a -1, which would be -2. So you see how the result, looking back to the definition, plugging in a negative is the same thing as just multiplying the entire result by a negative. So multiply 2 by negative, I get -2. You see how it passes the definition for odd? If I were to have done this but got 2 positives or something weird, or something different, then it would not be odd. Let me try to find some more pictures. Okay. Where's a good picture? Another way to think about it. In case you don't remember even or odd. So here's an even function. If I plug in an x and a -x, you see how the y values are the same, right? That means it's even, and there's symmetry through the middle. So it's another property of even functions. So you can fold it in half long ways, and it would be symmetrical, right? Now, odd functions, another way to think about this is if I use a positive and -x, the same number, just positive and negative versions, you'll have equal distance from the x-axis. If you don't, then it's not even nor odd. But I think just checking these definitions here is the easiest way to see it. It's just, you know what, is it the same deal no matter what I plug in, 1 or -1, then good, it's even. And if I can factor out a negative and get the same thing, then yes. All right. Anyway.
I think the concept makes sense. When I was doing the homework though, the part that really just kind of was hard to conceptualize was why sine is odd and cosine is even, right? Is that correct?
Yes, that's correct. Cosine is even, sine is odd.
Yeah. So
Bugging you as to why? Is that what you're saying?
yeah, why it is that way? Like conceptually, how you get there?
Okay. Here, actually, I have in that same thing I showed you, they have that example. Let me show you. So it comes down to symmetry. So here's the cosine function when you graph it. So you see how it's symmetrical on the y-axis, just like the parabola. So if you cut it in half, you get the same thing on both sides. And if you were to plug in values, for example, let's go back to the circle. So visually, it passes symmetry test. Analytically and by definition, cosine of 30 is square root 3/2, right? Cosine of -30 is the same thing. That is the property of even by definition. Does that make sense?
Yeah, I get that. Okay.
So if that happens, that means it's even. So if that's the requirement. And visually, there needs to be symmetry. That's what it means to be even. Like even has nothing to do with that power of 2, right? It's because of this and the symmetry. Does that help?
Yes.
Okay.
So that's actually the trend I was seeing earlier. It wasn't that it was 90 degrees. It's just that happened to be reflective of like the 45 degrees on each side. But obviously, if you look at that circle, like if they're even, like they're the same x coordinate, I guess.
Yeah. So for the even functions, you can use a positive or negative angle, and it'll be the same output. But for the sign, it would swap. It would swap from positive to negative. Let's see just real quick. So like sine of 30 is 1/2. Sine of negative 30 would be negative 1/2. That is the odd definition. Okay. Let me write down the properties. I didn't actually put that line too early. So that's the definition of even and odd, but here are the actual trig properties. So sine of negative theta is equal to negative sine theta. So basically the odd property allows you to pull out the negative from the inside, put it in the front. It's another way to think about odd. Cosine, you plug in a negative angle, it's as if you didn't. It's as if you plugged in a positive angle. It doesn't matter which one, they will be the same. That is a property of even.
From that, could you say if you plugged in a positive angle, it would come out negative for cosine, or is it not the same?
Yeah,
Vice versa?
you could. It would be the same. So
Okay.
cosine positive 30 is the same as cosine negative 30. They are equal. Okay. Tangent of negative theta would be negative tangent of theta. So these are sine and tangent. Actually, pretty much everything is odd except cosine and secant. So secant of negative theta is equal to secant theta. Cotangent of negative theta is equal to negative cotangent of theta. Cosecant of negative theta is equal to negative cosecant theta. All right. So let's do some examples, man. You guys okay with the definition so far? For me, definition always makes sense once I start to try to apply them. Okay. So example 1, we will use the periodic properties first. So cosine of 390 degrees. You agree that that's the same as saying cosine of 30 degrees plus 360, right? So now looking at the cosine periodic property, that would mean that it's equal to cosine 30, right? Which is very similar to the coterminal idea. that make sense? So instead of just doing a coterminal, you can just say, you know what, I'm gonna break off 360 degrees, and remember that up here, theta plus 360 is the same as just theta. So just change it. I feel like they're saying the same thing in a different way. Any questions? Example 1. Yeah, example 2. Cosine of, let's see here, negative 30 is equal to cosine of 30, right? That's what we said earlier. So you can just take this guy, which would be what? Square root 3 over 2. Now, if you were to have sine of negative 45, well, that would be the same as negative sine of 45, which would be negative square root 2 over 2 from the circle. So you see how the even and odd can help you out. I'm pretty much out of time, so I'm going to wait on the next part of 7.5. Let me look at the schedule.
So you just get these numbers from that circle chart.
Right. Now let's look at it real quick. So cosine 30 is the x value from the chart. That's where number 1 and number 2 came from at the very end. Sine 45 is the y value, square root 2 over 2. But you have to put a minus because of the odd property. But yeah, I was just looking at this.
Okay, thank you.
You guys have any questions or concerns or homework problems that you were stuck on?
So to be caught up, we should be done with 7.5 homework by next Tuesday.
I would say at least 7.4, because I didn't finish 7.5. So if you finish 7.5, you would be ahead, which is cool too.
Okay.
Let me look at the schedule real quick before I let you guys go. So we are in week 3. To give you an idea, I know you guys, some of you guys are very organized and like timetables. So we just finished 7.4 and almost 7.5. I will probably not be doing much of this guy. Trying to think. So I think on Monday, on Tuesday, today's Thursday, I will finish 7.5, which will take not much time at all. 7.6 and 7.7. Thursday, I will probably do 7.8 and the review. I may finish all of them on Tuesday. So Tuesday, we're going to do a lot of material because, well, we're going to do 3 sections. I mean, that's about average, but. So I would say working on 7.5 would probably be a good idea. That way you won't feel like you have a pile of homework. But also, like I said before, if you try out the homework before the lecture, it'll make more sense when we talk about it. I'm not saying finish it. I'm just saying look at it, try it out, and figure out what don't you know and what are they talking about, and then come to class. Tests I'm going to unlock probably on Monday of next week. You can take it anytime. Let me see. So today's week 3. Look at my calendar here. Week 3, week 4, week 5. So I think I said leave it open to the 21st. I don't know if we've talked about test 1 or not. But yeah, I'll unlock it on Monday of next week, and it'll be open for quite a while. So you can take it all the way until the 21st. I'm not saying take it right away. I'm just telling you that it's there. It closes on the 21st.
Is it timed at all? Like, once we started, do we have to stay there?
Yes. Yeah. It will be
Do.
timed. But yeah, we'll review next week. We'll finish 7 next week and start reviewing. And then you have the whole weekend. You have Friday, Saturday, and then you can take it Sunday night at the latest of the 21st. Okay. Now I might move it to 22nd. That way, if you want to stay up Sunday, it's not a big deal. Okay. I know some people like doing late night Sundays or something. You guys have any questions?